For Chapter 10, Section 1, we're going to talk about rational exponents and how we can simplify expressions that contain these. We've seen a little bit with radicals and like square roots and cube roots last chapter in Chapter 9 when we were dealing with the different types of graphing because we had graphed quadratics, and then we did a little bit of graphing square roots, graphing cube root functions, and cubic functions. So we're going to spend more time in this chapter kind of going over those different types of radical and exponential functions and how we can simplify them. So when you have a number raised to any power, you can rewrite that as something underneath a root sign. And so when I'm looking at something that looks like this is kind of telling me if I have a number or a letter raised to 1 over n, that's the same thing as finding the root of that number, and n could be anything. So this could be something raised to the second power, third power, fourth power, fifth power, and so on. So how we would read this specific one is just that it's the nth root of b, because again that n could change everything. Now technically there's like a 1 sitting right there next to the b. We normally don't write that just because we're more focused on the n term, whatever number is sitting outside of that root. So an example would be if you are looking for the root of something, you're trying to find a number times itself 3 times, 4 times, 5 times, whatever the root says in order to get that quantity that's underneath the root. So for example, if you were given the square root, which normally square roots are written like this, but just know that there's technically a little 2 there in the corner. You're looking for a number times itself, so you're looking for the same number twice in order for you to do this one, and so that would just be 6 for this problem. So another example is this next one here. I have 8 raised to the 1/3 power, which is the same thing as the cubed root of 8. So I'm looking for a number times itself 3 times. That would get me to 8, which would be 2. So I could write that out as 2 times 2 times 2 underneath that cube root sign. Or you can simplify this like we did in the past when we were working with our monomials and like simplifying expressions. We can rewrite that as 2 to the 3rd. And so if you can get the number out here and the number in here to match, then what's going to happen with those two things is they're basically going to cancel each other out, and the number that's sitting underneath that sign, so the 2, that's going to come out and be your answer. So the cube root of 8 is actually just 2, because 2 times 2 times 2 would be 8. So when you're looking at a problem like this, there's a couple things that you just want to be familiar with. The first thing is the index, and that would be the type of radical that you're dealing with. So it would be the number outside of the radical. So the radical is this symbol and then whatever number is sitting right there in that X spot. So that could change depending on what kind of problem we're dealing with. The radical sign, like I said, is that's, you know, the traditional square root sign, but just know that radical signs can also look like this, or this, or this, and so on. The radicand would be the number inside of the radical. So for example, if I have the square root of x, x would be known as the radicand, because that's the number that's sitting underneath that symbol. Now, a couple rules that we need to be familiar with when we're dealing with different types of roots, because you're going to have some that is an even root and you're going to have some that's an odd root. So when you're dealing with an even index, so the root symbol or the radical sign is there and the number up in the corner is an even number. So 2, 4, 6, 8, so on and so forth. So if you're dealing with an even, the number underneath the radical is, if it's positive, then the answer is going to be real. If the number underneath the radical is negative, then the answer is going to be what we call imaginary, which we've talked briefly about imaginary numbers. We haven't gotten into a whole lot of detail about it, but here's what an example of that would look like. If I was trying to do the 4th root, because that's an even root, of something like this, negative 16, Think about your multiplication rules. If you take a negative times a negative, you always get a positive. So if I'm taking something times itself an even amount of times, whether it's positive or negative, my answer should always end up being positive. So if it's a negative times a negative times a negative times a negative, well, there's 4 of them. That's an even amount. They're going to end up being a positive answer. So if I have a negative number sitting underneath my root sign that has an even index, that causes a slight problem because there's really not a real way for us to have gotten to that point. So we're going to be talking about this little piece here, -1. And so what you'll see us do when we're dealing with the negatives underneath a even radical is you're going to have this -1 kind of get pulled out just to kind of get rid of the negative issue that we're seeing. And then we're going to deal with the number as a positive. So think of this as like -16 times, or -1 times 16. And so the fourth root of 16 would be the 2's. So 2, 2, 2, 2. And if I multiply those, that would get me my 16. So how I would write my answer here is I would pull this 2 out, because that's 2 to the 4th. And like we saw up above, you know, the 4th root and the 4 to the power, those are going to cancel. So that 2 is going to come out front. And then underneath the radical sign, we're going to keep that -1 because it was a -16 to begin with. This is representing what I said up here is that your answer is going to be imaginary. So how we know imaginary numbers would be using the letter I. So like I said, you won't see a ton of this case just because we keep it pretty brief in algebra of how much you deal with the imaginary number. You'll deal with the imaginary number a lot more when you guys get to Algebra 2 and kind of see how you can work with different expressions that involve the imaginary number. But just so you're aware that if you see a negative underneath an even root sign, that does mean that there's something going on within that, and that's usually because there's that imaginary number I in there. Another example that you might see is when you're talking about finding like the answer of something. So like the square root of 4. We know that we could do +2 times +2, or we could do -2 times -2. And so if I write my answer, it's going to be plus or minus 2. So anytime that you take a root of an even, so if you're doing a square root, a 4th root, 6th root, 8th root, so on, you're always going to have a plus minus sign in front of your answer because, again, like I was explaining earlier, you can take a negative number or a positive number times itself an even amount of times and still get a positive answer. So when we take like the square root of something, there is technically that positive answer and that negative answer because I could have gone both ways with that and still gotten that positive. If you have an odd index, so if the number underneath is positive or negative, but you've got like the cubed root or the 5th root, the 7th root, so instead you're dealing with those odd numbers. These are a little bit simpler to deal with. The number underneath the radical can be positive or negative because, again, if you have an odd number of signs, it could be positive or it could be negative depending on what type of numbers you're dealing with. So a little less restrictions on how you have to write your answers when you're dealing with the odds. For example, the cube root of -27 would just be -3. -3 times itself 3 times is going to get you that -27 underneath the power there. So let's take a look at some examples together. For example, if we have the square or the 36 raised to the 1/2, that is the same thing as saying the square root of 36. So an easy way that you can do these kind of problems if you're not great at like just knowing what your square roots are or your cube roots are is you can think about taking the number underneath and like factor treeing it, and you're looking for like groups of numbers that you could multiply together to get to 36. Now because I'm dealing with a square root, I want to try to think of like a group of 2, so a number times itself. So like 6 times 6 would be 36. And so when I find my group of 2, so this is a group of 2 here, this would be the same thing as rewriting it like this, the square root of 6 squared. And then the square root and the power of 2 are going to cancel each other off. And so that 6 is just going to come out and be our final answer here. Now this next one, we've got negative 125 raised to the 1/3 power, which is the same thing as the cubed root of negative 125. So we can approach this the same way we did the last one. I'm going to be looking for a group of 3 this time because of that 3 out there in my radical. So 125 could be written as 25 times 5, and then 5 could be factored down to 5 times 5. And so there's my group of 3. I've got 3 5s here. So it's going to be a 5 that comes out, but because there's a negative sitting underneath that square root, or that cube root sign, I want to make sure that I make the 5 negative, because negative 5 times negative 5 times negative 5 would get me that negative 125 that I'm looking for underneath that radical sign. So I want you guys to take a minute and try to do these next 2 practice problems on your own, and then when you're ready to see the solution, go ahead and keep watching. So 64 to the 1/3 power would be the same thing as the cubed root of 64. And now I'm going to factor tree my 64 like I did before on those last couple of examples, and I'm looking for a group of 3 for this problem. So 64, I could do 16 times 4, and for 16 I could do 4 times 4. So there's my group of 3. So the cubed root of 64 would just be a 4. For the other practice problem here, we have negative 81 to the 1/4 power, which is the same thing as the 4th root of negative 81. Now you'll have to be careful on this one because you have a negative underneath a radical sign that has an even index. So we'll have to make sure that we take care of that by expressing negative 1 underneath our square root sign. So for right now, just think about the 81. So that would be 9 times 9, which that's a group of 2, but I need a group of 4. So I'm going to factor 9s down to 3s. And there's my group of 4. So this would be 3. That would come on the outside. But then I'm going to put that negative 1 still underneath the 4th root because I have a negative 81 underneath here. So I need that negative to still be represented somehow. Now we can extend this idea a little bit further and still deal with numbers, but also have letters involved. So when you're dealing with the number portion, you're going to handle that the same way that we've been doing on those previous examples. So for this negative 125, I'm looking for a group of 3. So we did this one earlier. We're going to factor this as 25 times 5. And then 25 would be 5 times 5, and that gets me my group of 3 for my numbers. Now when you're dealing with the letters, so your variables with the exponents, what you want to see happen is your variable needs to be raised to a power that is easily divisible by the root. So in this case, I have a to the 6th power. So I would want my 6 to be able to be divided by my 3, because that's in that radical sign, which it is. So I've got this negative 125, and we found our group of 3 of 5s there. So my 5 is going to come out, and it's going to be negative because, again, we've got that negative in front of the 125. And then for your A, you're going to take 6 divided by 3, and that would be 2. So this would simplify to negative 5A squared. Okay, so you guys go ahead and try this practice problem. So I have 16. Now this is just a regular square root, so I'm looking for a group of 2. So I'm going to factor tree 16 as 4 and 4. So there's my group of 2. Now there is a negative sign here, but that's sitting out front. Okay, so it's just going to make the 4 negative because it's sitting out front of the radical sign, which is not a big deal. Now for your letter, you have x to the 10th power. So you're going to want to take 10 and divide by that little 2 that I said is technically sitting in that root there. So 10 divided by 2 would be 5. So you should have gotten negative 4x to the 5th. Now, those examples had letters that were raised to exponents that already were divisible by the root that you were dealing with. I need to show you how do you handle it if you don't have that working out for everything. So if you have letters that are raised to other powers that you can't just easily divide, like what do you do? So when you're trying to simplify a radical expression, so it's got numbers and it's got letters, factor the number the same way that we've done before. Try to find your group of 2 or 3 or 4, whatever your root is. Then take a look at your letters. Now, if your letters are not right away easily divisible by whatever the root is, then we're going to have to split our letters apart. So I want you guys to think with me for a minute back to what we did in Chapter 7. So Chapter 7 was when we started talking about like these monomials and polynomials for the very first time, like multiplying letters, what do you do with their exponents, those kind of things. So if you had x to the 5th power, that meant that you had 5 x's. Okay, so we could have written it out as x times x times x times x times x. If I need to do that for these problems to split it so that I can get like remove an x or remove 2 x's so that I can get a number that's easily divisible by the root sign, you can do that. You can split your letters apart in order to get ones that are going to be more easily divisible by those root symbols. So let me show you this example so you can kind of see what you would need to do and kind of how to handle these other ones when you go forward. So I've got the cubed root of 24 x to the 6th power, y to the 5th power. So I'm going to factor tree my 24 and I'm going to try to look for a group of 3. So 24, I could rewrite that as 2 times 12. And 12 I could rewrite as 4 times 3. I still don't have a group of 3 yet. 4 could be 2 and 2, which there's my group of 3. 3 2's. I don't have to worry so much about the 3, but I will have to kind of take it into consideration when I'm writing out underneath my root here. So I've got the cube root. Okay, and I'm going to rewrite this now. So I found 3 2's, so I'm going to write that as 2 to the 3rd. But I still had this 3 left over, so times 3. Because 24 doesn't factor perfectly to just a group of 3. There's going to be that little bit left over. Now let's talk about our letters. So if I look at x to the 6th power, so again, I'm really kind of just focusing on like what are these exponents. 6 is divisible by 3. So I'm not going to do anything to the x. I'm going to leave this as x to the 6th power. Now y, 5 is not divisible by 3, right? So I need to try to think about y and split it up. Now remember, that means that there's 5 y's. So what I'm going to do is I'm going to kind of think about if I split off 2 of them, I could rewrite y to the 5th as y to the 3rd times y squared, like this. Okay, so now that we've written this expression out, what we're going to start doing is taking things out of the root and putting it in front of the radical. So that would be anything that has a group of 3, like the 2's, or the letters that have exponents that are now divisible by 3. So 2 to the 3rd, you can think of this as, you can still kind of follow the same rules with the exponents. So you can take 3 divided by 3, and that would be a 1. But this 2 is going to come out of the root sign. So no more radical sign over that 2. That's going to come out. And so I'm just going to cross that one off and work my way down the list. Now 3 has an exponent of 1. I can't take 1 divided by 3. So I'm going to have to leave 3 underneath the radical sign. But I'm going to skip over that for now because I'm going to see if there's anything else that I can pull out. So x to the 6th power. 6 divided by the 3 out here is going to be 2. So this is going to become x squared, and again that's going to come out of the radical sign. Y to the 3rd, 3 divided by 3 would be 1, so y to the 1st power, or just y, is going to come out. And then last is this y squared, which I can't take 2 divided by 3 nicely. So just like the 3 that we had here, the 3 and the y squared are going to have to remain underneath that root sign. So we're going to draw a cubed root, and we're going to put a 3y squared underneath it. So the only things that you can pull out are those groups of 3 or those exponents that are raised to numbers that are divisible by your radical root. Anything else will have to stay. So this is the answer that we would end up with. So there's a couple practice problems. There's this one and there's this one. I want you guys to go ahead and try to do both of them. So pause your video and work through those examples, and then when you're ready to see if you got them right, go ahead and keep watching and I'll show you the solutions. So for this first one, we're dealing with a fourth root, which means for my number 162, I want to try to find a group of 4. So I'm going to factor tree my 162. I did 2 times 81, then I did 9 times 9, still don't have a group of 4, but my 9s will split to 3s, and that's where my group of 4 comes from. And I still have this 2 left over. So when I wrote it out underneath the fourth root sign here, I have 3 to the 4th power times 2. Now let's talk about our letters. 6 and 3, neither of those are divisible by 4. So x to the 6th power, let's break that apart. So if I take away 2 x's, and I rewrite this as x to the 4th and x squared, that x to the 4th will be divisible by 4. X squared won't be, but that's okay. We can always just leave that underneath the radical sign. And that's still x to the 6th power. Because remember, you would add those back together if you were going to combine it again, and you're still back at x to the 6th. Now, y to the 3rd, there's really no way for me to break that apart to make it divisible by 4. Because 3 is already too small, so I'm not going to be able to do anything with that y. So the 3 to the 4th power becomes a 3. That comes out of the radical. 2 will have to stay. X to the 4th becomes just x, and that comes out. And the x squared and the y to the 3rd will have to stay underneath my radical sign. And so that's how I would have written my final answer for that first practice problem. For this one, you're dealing with just a square root. So remember, that means that there's a 2 here in the corner. 90 could factor to 2 times 45. 45 could be 9 times 5. And 9 would be 3 times 3. So we've got your prime numbers here. And my group of 2 is that 3 squared. So 3 squared times 2 times 5 would be my prime numbers. Okay, for my x to the 3rd, I would have split that apart to x squared times x. Y to the 4th, 4 is already divisible by 2, so I don't need to split y to the 4th at all. And z has an exponent of 1, so I'm not going to be able to split z at all in order to get that to be simplified. So I'm just going to leave that one as is. So final answer here, the 3 is able to come out. The 2 and the 5 will have to stay. The x squared becomes an x, and that comes out. This x will have to stay. Y to the 4th becomes y squared. And z will have to stay. So underneath the square root sign, you can then simplify 2 times 5 as a 10. And then x, z.